Hi to all. In the last video we had discussed about sine bar. So in this video we are going to discuss about the sine center. Welcome to all to my video on mechanical measurements and metrology. Coming to, let us have a glance on sine bar. It is about measuring the inclined surface of a given specimen when the specimen is kept on a sine bar. As I am showing here, the inclined surface is made exactly parallel to the surface plate, and then the angle is being measured based on the similar triangle concept. Both angle will be equal to theta, which is defined as theta is equal to sine inverse of capital H by L. H is nothing but the height which is being raised with the help of a slip gauges. L is nothing but the distance between the two rollers. That is how the angle is measured for an inclined surface when it is kept on a sine bar. And at the same time, some of the important accuracy requirements, as we had discussed in the last video, it is about axis of rollers must be parallel with respect to each other, and it holds good even for the sine center also. And top surface of the sine bar must be flat, and that doesn't make any sense in case of sine center because the specimen is kept between the two opposite centers. Okay, the axis of the two rollers must be parallel with respect to each other. That again holds good even for the sine center. The rollers must be of identical diameter, and it should have minimum out of roundness or no out of roundness. Okay, some of the limitations being like minimum angle, maximum 15 degree gives a very good accurate readings. Above 45 degree, the angle when it is being exceeded, there are more impractical and inaccurate readings are obtained. Maybe due to 3-4 reasons which we have discussed in the last video. Coming to the sine center. The sine center here, it is mainly used to check the semicone angle of a conical workpiece which is being mounted between the centers of the sine center. The conical workpiece is being mounted between the two centers of the sine center. So here to make the top conical surface horizontal, the sine center has to be tilted through an angle of theta, similar to the inclined surface angle measurement in case of sine bar. Bar height with the help of a slip gauge stack h. The slip gauge height h can be found by using the sine formula, as in case of similarly sine bar. The procedure followed in the sine bar and sine center both are same. There we are making the top surface of the sine bar to be parallel with respect to the surface plate. Similarly here also the top surface of this tapered specimen, okay, considering it as a single line because it is a circle, conical tapered surface, it is a circle making a tangent to this tapered surface. Considering that parallel to the making that surface to be exactly parallel to the surface plate, that is being ensured with the help of a mechanical comparator, okay, or nothing but the dial gauge. If there is a deviation 0, if the deviation is 0 in the dial gauge, then that means to say it is perfectly flat, and at the same time it is parallel with respect to the surface plate. And then the angle theta is being calculated. This theta will be equal to the half of this tapered angle, nothing but the semicone angle alpha. Okay, that is how the sine center is used for checking the semicone angle of a tapered surface. I repeat, the rise in the one roller is attained with the help of a slip gauge stack, which is whose height is equal to capital H. Okay, that is being calculated with the help of a sine formula. Theta is equal to sine inverse of capital H divided by L. Okay, and delta H is also being considered here. And then the this mechanical comparator or nothing but the dial gauge is being slided or moved over the top surface of this conical surface or nothing but the tapered surface. When the deviation is 0, then that capital H is considered to calculate what is the angle of the semicone angle of the given tapered specimen. Okay, and measuring the tapered angle is very important even in case of machined components or different components which is being used in assembling of various machines. Okay, that's why. And if it is again the same holds good here also, when it is less than 15 degree, then obviously the accuracy and practical importance is very good, whereas when it exceeds the more than 20 degree 30 degree, obviously it gives some amount of error, because it may be one or the two other reason, one being like the number of stacks or slip gauges in a stack is going to increase. Because of that, some part of the error is going to be inherent in that. Okay, and again there are many more which I discussed with respect to the sine bar. The whole it same holds good here also. Okay, it is about angle measurement using the sine center. Next we'll go to the clinometers. Clinometers or clinometers is nothing but it is one of the another important angle measuring instrument, I can say, where the specimen can be kept on a table of a clinometers. So let me go with the clinometers. Clinometers is a special case of the application of a spirit level. That is another important part of this clinometer, where spirit level is used to check the inclination. That is in case of sine center and sine bar, we are going to ensure that the surface is parallel to the surface plate with the help of a dial gauge or a mechanical comparators. But at the same time, here in case of clinometers, spirit level is used to check the flatness or no zero inclination of the given specimen. Okay, on a rotary member carried in a housing. The bottom end of the housing forms the base of the instrument. Bottom end of the housing forms the base of the instrument, which houses many components of this clinometers. On the housing there is a circular scale. First one, the angle of inclination of the rotary member carrying the spirit level relative to its base can be measured by this circular scale. And then the clinometer is mainly used to determine the included angle between two adjacent faces of the workpiece. The clinometer is mainly used to determine the included angle between the two adjacent faces of the workpiece, similar to the optical wheel protractor also. Thus, to measure the included angle, clinometer's base is first placed on the top surface of the workpiece. Clinometer's base is first placed on the top face of the workpiece, and rotary member is adjusted till the bubble is exactly at the center of the spirit level. We have to understand here, I think many of you know how to use the spirit level. When the spirit level is kept on any kind of surface, if the bubble is moved on any either sides with respect to its center, then we can understand that there is an inclination of this surface. When the bubble, a bubble in that tube is exactly at the center, which is being marked, okay, when it is at the center, we can understand that the surface is exactly flat or perfectly flat, and there may be small deviation which is beyond the measurement of the spirit level, that we can neglect it, but to a greater extent it is perfectly flat. The angle is then noted on the circular scale. So here understand the procedure with respect to the clinometer. First, the clinometer base is first placed on the top face of the workpiece, and the rotary member is adjusted till the bubble is exactly at the center of the spirit level. The angle is noted on the circular scale. That is the first step how we are taking the reading. And then in the next step, the second reading is taken in a similar manner. Example, let me assume that Let me assume that this is having a inclined surface. I think many of you can see there is an inclined surface. What I will do is, first let me consider this as a first phase. Okay, I will keep this flat surface on the clinometer, and I will adjust the spirit level such a way that it is at the center, and I will take the reading on the measuring scale or a rotary scale of this clinometer. In the next stage, that is to take the second reading, I will keep this inclined surface. I will keep the inclined surface exactly on this clinometer. Okay, again I will try to adjust the top surface. I will try to adjust this table of this clinometer such a way that the spirit level is made parallel, or spirit level is considered making the air bubble to be at the center. Okay, adjusted such a way that in the spirit level the air bubble is at the center. And then what is the second reading, that is how much it is giving the reading in the second stage, in the second trial, that is being noted down. The difference in the reading will get in the difference in the reading we will get it as this included angle. Okay, this as a included angle. This included angle mean to say, included angle is always nothing but the angle between any two adjacent surfaces. Let me say this as a surface 1 and this as a surface 2. Okay, so the angle here, this angle is nothing but included angle, that can be measured with the help of a clinometers. So this is a here you can see the actual picture or real picture of this clinometers. Here you can see there is a spirit level. Okay, over this table this surface is being work table or a table of this clinometer. Okay, that need to be adjusted. So clinometers, they are also used for checking angular surfaces and relief angle on large cutting tools. Especially that is a very important application or a widely used clinometer application. Okay, so that is measuring the relief angles of large cutting tools and milling cutter inserts. Further, they are also used for setting jig boring machine tables to any desired inclination. That is another important. That's why this clinometer plays a very important role in the shop floors where manufacturing is a primary aspect. Okay, jig boring machine tables to any desired inclination and angle work on grinding machines. These are some of the applications. In another type of clinometers, there is no spirit level, hence a bubble, but depends on its operation on a circular plate supported on fine ball bearings. The circular plate is designed such a way that when it is being released, it always take up the same position relative to the true vertical direction or true vertical. The angle of the body is then read against the circular plate to an accuracy of L or 1 minute with the help of a vernier, and then the angle is being calculated. That is how the clinometers are used. Now, okay. So this is about the different types of angular measurements rather than some optical we are not going to use too much of optical principles. Okay, we are just using the optical instruments to magnify the readings, that's it. Okay, now we are going for instruments which are using the optical principles to check any kind of surface deviations. Okay, one such example or a best example for such optical instrument for measuring of angle is autocollimator, and it is one of the widely used type of angle measuring device. Also, it gives a more precise and accurate reading of the surface inclination. Okay. So, four principles which governs the applications of optics in metrology. The first one is magnification, which we have seen already in case of optical comparator. optical bevel protractor, which magnifies the reading of a vernier calipers. Okay, or when you can say in further cases you can see that the readings are being magnified with the help of optical principles, which provides visual enlargement of the object, that is as similar to the bevel protractor. Magnification enables easy and accurate measurement of the attributes of an object, that is nothing but the readings of an object vernier calipers. The second one most important is accuracy. A monochromatic light source which provides absolute standard of length and therefore high degree of accuracy can be ensured when a monochromatic light source is being used. The third principal one is alignment, which uses light rays to establish surface references such as lines and planes. And the fourth important and the most significant one is the principle of interferometry, which is a unique phenomena associated with light, and it is widely used concept or a phenomena for metrological concepts or some measuring instruments. Okay, for developing some measuring instruments. Autocollimator is one such instrument which uses the principle of the interference. Okay, so coming to the first point, here the important thing is about reflection. The common important concept of the light or optics which we are using in autocollimator is reflection. Let me say a surface is perfectly flat. Okay, when the surface is perfectly flat and a monochromatic light source is being emitted and it is made to fall on a perfectly reflecting surface which is perfectly flat. Okay, let me assume that it is perfectly flat, then obviously it is reflected back. Okay, it is reflected back in the same direction, in the same angle. Okay, with the help of a collimating lens it is being converged and the point is being checked, where if it is there is no any deviation, then obviously we can say that the surface is perfectly flat, which is kept at an 90 degree with respect to the rays emitting direction. The direction, the angle between the emitted rays and the plane reflector is exactly perpendicular with respect to each other. Then we are getting the reflected rays in the same direction, in the same angle, and it is converging at the same point. Then obviously there is no any deviation. So the important two principles used in the autocollimator is, first one, the the projection and the refraction of the parallel beam of light by a lens. If there is 0 degree reflection, then obviously the surface is perfectly flat. If there is any deviation, okay, if the change in the direction, when the surface is being changed by an angle of theta, then obviously the angle which is being reflected, the angle at which it is being reflected changes to 2 theta. Okay, and when it is being converged, obviously the angle which is converging at the angle of theta. So reflector angle is not right angles to the direction of rays, then obviously there will be a change in the angle, and where it is being converged, the focal plane is considered. Okay, the angle at which it is being converged, that is being counted, and that will be the inclination of this focal plane. We can check it and we can say that there is a deviation, and this length, the distance between O and O dash is being calculated, and the angle is also being calculated using the trigonometric concept. Okay, so the length between O and O dash is being calculated by using the optics or nothing but the microscopes. Okay, with micrometer attached, and then the length, you're using the length or the distance between O and O dash using a trigonometrical concepts, we can calculate what is the angle theta. Okay, that is the basic principle on which the autocollimator works. So in actual practice, the work surface whose inclination is to be obtained forms the reflecting surface, and displacement x is being measured by a precision microscope. X is nothing but the displacement, which is where the distance between O and O dash, that is being measured with the help of a highly precision microscope with micrometers attached to it, which is calibrated directly to the values of inclination theta. and the target surfaces are illuminated by electrical bulb and act as a source of light. Since it is not convenient to visualize the reflected image of a point and then to measure the displacement x precisely, so obviously we are using the different sources here. One is illumination, filter is being used, and diffuser and objective reticle. So here initially what we do is, like in this principle, generally the light is being illuminated with the help of a filter and condensers. As light is converted into a monochromatic light. Whatever the different light source, the light source which is being emitted, the light which is being emitted from the light source, that is being converted into a monochromatic light, and then objective reticle is present here, and objective lens is present here, and there is a eyepiece. The eyepiece which is observing the light, okay, and from here when the light is being emitted from this objective reticle, okay, the user generally observes the image from this eye reticle or eyepiece. And here there is a splitter. The light splits. The light is splitted. One is onto the surface and another is being to the to the eyepiece. So once the surface is being checked, here you can see there may be a change. The image of the illuminated wire after being reflected from the surface being measured is formed in the same plane as the wire itself, because when the eyepiece through the eyepiece the user is observing this reflected image as well as the source image. Okay, so here obviously one image is being reflected, and there is a crosswire which is present in this eyepiece. The eyepiece system contains a micrometer, microscope mechanism with a pair of setting lines which can be used to measure the displacement of image by setting to the original cross lines. Nothing but example. Let me say the object is placed at a position, and let me call that position as 0th position. And when I move it for a further distance, the distance is being calculated. Okay, the displacement is being calculated, and what is the inclination or the displacement in the image, that is also being checked. The displacement in the image is being checked with the help of a cross wires and the micrometer attached microscope mechanism. Okay, the distance of this image which is being moved, okay, along with the with respect to the 0 position, that is being compared, and the displacement x is being calculated, and that x is used to calculate what is the difference in the angle, that is the angle theta. The calibration is supplied with the instrument, thus the angle of inclination of the reflecting surface per division of the micrometer scale can be directly read. Example, here let me clear further. A calibrate one aspect or one method of measuring the angle is which I already mentioned. The other method is a calibrated surface is given to you along with the instrument. But when you place the surface, when you place the calibrated surface, okay, you are getting some reading. You are getting some reading. Let me call that as a 0th reading. Okay, and then the inclined surface for which the inclination you have to measure it, that you are keeping exactly opposite to your eyepiece, exactly opposite to this objective lens. When it is kept in the same location, let me say the distance from the objective lens to this surface as well as the initial position where the calibrated component is kept, both are at a distance, let me call it as at 25 centimeters or 50 centimeters. Okay, so at a 50 centimeter the objective lens and the calibrated object is kept, and you have taken that micrometer reading such a way that the cross wires is placed exactly on the mark of this calibrated object, and then the calibrated object is replaced by the inclined surface for which the inclination is supposed to be measured, and then you are checking that there you can see that the image is being shifted, the image is being shifted. So what is the shift in the image? That distance, the displacement of the reflected image, that x you are going to calculate with the help of a micrometer. Okay, So when you calculate the difference in the reading, you will get the displacement x. Okay, that x you are going to use with the help of a trigonometric concept. You are calculating what is the angle of inclination, and here we need since it is based on optical instrument, they are highly accurate and it can read up to 0.1 seconds, which is a very close and dimension tolerance, correct. And also they can be used to measure distance up to 30 meters. That is the major advantage of autocollimators. Another important application of autocollimator for checking squareness. If I want to have manufactured a component, I want to check what is its squareness. Okay, so yeah, a perfectly square or a rectangle, then obviously the two adjacent sides angle between any two adjacent sides should be exactly 90 degree, correct. And at the same time, here we can see there is a angle which we can measure it with the help of a autocollimator. So we can use it for checking the squareness. So let me call this as a object. Okay, you let me consider as an object. Initially, the autocollimator, with the help of an autocollimator, a light is being illuminated on the one surface or one edge of this object, and when it is being reflected back, if there is no any displacement, or then we call it as it is perfectly perpendicular. It is perfectly perpendicular with respect to the autocollimator. Okay, and let me call this reading as L1 or R1. Let me call this reading which is taken at this position as R1. And opposite to this, a mirror with base on vertical surface is being kept. Mirror with base on vertical surface is being kept, and the light is being reflected. When the light is being reflected, again the another image is being reflected in this direction. So when I move the autocollimator from this position to the very new position, which is where I can see the mirror image of this another surface. From this direction, if I can see the image with the same angle, okay, with the same angle, obviously these two edges are perfectly perpendicular with respect to each other. If there is any deviation or the displacement, obviously I can say that there may be some deviation in the edge. If they are not exactly perpendicular, there may be an error which I can measure it with the help of a new location. That is how the squareness can be checked or measured, or it can be ensured with the help of a autocollimator. Okay, so that is another important application of autocollimators. Even the angle decors are there, where you can go, you can check it through different sources. It is an assignment for you, and it is a very important application of this autocollimator. It is angle decors or the other form of autocollimator. Okay, so this is the angle decor, where you can see the again the flatness of a flatness of a given surface. Fixed datum. Okay, let me give some clue here. A workpiece which we cannot keep it vertically, and we can check what is the inclination of the surface, where the object need to be completely rested on a surface plate. Then obviously we are going, or nothing but the heavy components. For that such kind of surfaces, we use the angle decors, where the workpiece is kept on a table, and autocollimating lens which is present somewhere here, and then the light source and the objective lens. Here there is a light source. Here you can see there is a light source which is being emitted through the collimating lens on the object, and then there is a eyepiece. Okay, when the light is being illuminated, or nothing but it is being made to fall on this surface, because if there is any variation, there is or when it falls on the surface, it causes the interference. Okay, and this interference lines or phenomena is being observed with the help of a eyepiece. Okay, and if there is any deviation with respect to the eyepiece, that need to be taken. If the surface is perfectly flat, then the interference lines interference will be very minimum or nothing, but it is exactly reflected back with the same focal length. Correct? If there is any deviation, obviously there may be a chances of the change in the focal length or nothing but the displacement which we can obtain similar to the autocollimator. The distance is fixed initially, a fixed datum line is being used on a surface plate, and the reflected image of the illuminated scale that we can see here. Exactly the image is perfectly at the center of this scale is perfectly center of this illuminated image. Here we can see the horizontal scale, there may be a change in the deviation. That deviation we have to bring it to 0, and then we have to calculate, or we can see directly here what is the reading view in the eyepiece. Here when there is a deviation, that deviation we have to note down, and that we can call it as a displacement x, and we can calculate the angle theta. This is how the angle is measured with the help of angle decor. In detail you go through the textbooks. It is a very important application of the angle decor for heavy components. Okay, so I think as per the VTU syllabus, the module 1 completes with this video. The module 1 completes with this video. Thank you one and all. I have used many resources from both internet as well as from textbooks. I acknowledge all such sources for which has been used for preparing this teaching material. Thank you one and all for both sources as well as for your patient listening.